Hey everybody, thanks for tuning in. So in the last video lecture, you learned about the celestial sphere, which is a tool that we use to model how the sky changes over the course of one day. And so you also learned that depending on where you are on Earth, you get a different view of the sky. And basically, I'm talking about your latitude. And the reason for why that is because if you look down, the Earth is literally blocking that view. And if you look up, then you see, the sky that you're able to observe. And so in this lecture video, we are going to extend that discussion even further and observe how the sky will change at different parts of the Earth over the course of one day. So let's just jump right in here. So let's start off here with the extreme ends of the Earth, and I'm talking about the North and the South Pole. And so we know that the Earth rotates about an axis, and these 2 points on the Earth are actually contained in that axis. So in other words, the Earth rotates about these 2 poles. And so if you imagine yourself living at one of these poles, so let's put a person on the North Pole, and if they were to look up, then they're going to be looking at the direction of the North Celestial Pole. That's shown here in this figure on the bottom left. And so what ends up happening is because if the Earth is rotating about this axis and you're on that axis, you're basically spinning also about the same axis. And what ends up happening is that you're going to be seeing the same half of the sky at all times. And so figure B here shows what this person at the North Pole, and if they were looking up, this is what they would see. And so this dot in the middle represents the North Celestial Pole. Now there's an actual object there, and we're very close to it. It's called the North Star, or Polaris. And so if you were to wait and track the motion of the stars for 24 hours over the course of one day, then you'll actually observe all of these stars to rotate counterclockwise about the North Celestial Pole. Now, if you were living in the South Pole, it'd be the exact opposite. You would actually observe stars rotating about the South Celestial Pole over the course of 24 hours. So the consequence of that is that whatever star is going to be above your horizon, then all of those stars are going to be up all day, all night. So in other words, there are no stars that are rising or setting. All stars are circumpolar. So that's a special word that we use if a star is actually up for the full 24 hours. Figure C here is basically showing you the celestial sphere for a person that's going to be living on the North Pole. And so this green circle here represents this person's horizon. So think about that horizon as separating the visible and the invisible region of the sky to an observer, like this person at the North Pole. And so anything above the green circle here, that person can see, and anything below, this person cannot see. And again, because they're on the North Pole and the Earth rotates about that axis that contains the North Pole, basically all of these stars are pretty much just going to be going in circles relative to this person. So therefore, they won't be rising or they won't be setting. Okay, so now let's put our observer here at the equator. So now they're basically right here. And so now they're going to be basically rotating at the furthest edge of the Earth. And in this case, if this person were to look basically in the direction of north, directly north, then on the horizon, very low on the horizon, they're going to be looking at the direction of the North Celestial Pole. Now, if they were to turn around, for example, and look again in the direction of south, then what they're effectively doing is they're going to be looking at the South Celestial Pole, okay? And so now let's see what happens here for this person who's going to be at the equator at a particular time. So let's say 6 a.m. So if this person is here at 6 a.m., then because the Earth is rotating, 12 hours later, now it's going to be 6 p.m. or, about sunset. And you got to think about what this person was seeing when at 6 a.m. because they're seeing basically the right half of this figure here as their sky. 12 hours later, now they're seeing the left half of the sky. And so over the course of 12 hours, they were virtually able to see the whole sky. And in that period, some stars rose and some stars set. And in fact, when you're at the equator, all stars actually rise and set. And your celestial poles are going to be on your horizon. And so as the Earth rotates one full cycle, and you can see that here on the figure on the right, then the entire night sky will be visible at some point. Okay, and that's only if you're at the equator. Okay, so now what happens if you're actually somewhere in between the equator and one of the poles? So that's called an intermediate angle. So for example, if you're living in California, then you're at 30 degrees, about 30 degrees north from the equator. So that's an intermediate angle. And so in that case, one of the pole is always going to be above your horizon. So in California, because you're in the northern hemisphere, that means that you are able to observe the North Star at all times for 24 hours. And here's a key idea here. If you're at some latitude, so let's say again, California, you're at about 30 degrees north, that is also equivalent to the altitude of the visible pole. And so in this figure, this person again is at 30 degrees north. And if they were to look in a direction of north on the horizon, and then they lift their head up 30 degrees above the horizon, that's basically 30 degrees altitude, they will see the North Celestial Pole. Okay, so they will see the North Star 30 degrees above the horizon. So on the figure on the left, this kind of illustrates what this person is seeing over the course of one full cycle. And if you look at this person at this specific time on the right side of this figure, then you can see that basically this half of the sky is going to be visible, what I'm hovering over with my mouse here. And then wait 12 hours later, the Earth would have rotated halfway, right? So now this person's on the opposite side of the Earth. Now this half of the sky is going to be visible. And so think about that in that process. Basically, it formed kind of a cone, and this cone kind of defines a region where stars were always visible relative to this person. However, on the flip side of it, it also formed a region of the sky where this person is actually unable to see it at all times. So that's going to be here on the bottom, shown here in the green, bottom part of this figure. Okay? And I do want to go back to the previous slides here just to kind of illustrate this idea that, the altitude of the visible pole is equivalent to your latitude on Earth. And so now let's go back one slide over. So if you're at the equator, right? If you're at the equator, then that is defined as 0 degrees latitude. And if you were to look out into your horizon facing north, well, the North Celestial Pole will be at that horizon. So basically 0 degrees altitude. And then now, if you go to the North Pole, go back to this person, and in order to see the North Star and also look in the direction of the North Celestial Pole, what does this person have to do? Well, they have to look straight up. They have to look at their zenith, right? And that's defined as 90 degrees altitude. But what's their latitude? Also 90 degrees, right? Because the equator is right here at 0, and you go all the way and that's basically 90 degrees north. So it holds true for whatever location you're at. And so I encourage you guys, like at night, that if you have a pretty clear view of your northern horizon, just look up about 32 degrees, and then you should be able to see the North Star there, and that's called Polaris. And so what I'd like to do now is kind of just show you guys what this actually looks like if you were able to fast forward time. And with that, let's actually go to Stellarium. Okay. And so first, let's go to somewhere near the North Pole. And so let me just go back to that real quick, actually. So in order to change the location on Stellarium Web, you can just click on this bottom left region here where it says Greenland. So I already actually had it set. And then I can just zoom out from the map. You can use your mouse wheel if you have one, or there's like these little buttons right here. You can press minus as much as you want, so you can zoom out, and you can be able to see the world map. And there's no setting for, there's no preset location for the North Pole, so you kind of just have to manually drag this little marker and place it as far north as you can. So you're kind of just approximating here. That's what you're doing. Okay, so I'm just going to use that location. And so what I'll do here, now we're at Greenland. I'm facing north, and I had my constellations turned off, so you can see. What I would like to do, though, is I will turn off my atmosphere so I can basically see all of the stars in the sky, because it's still bright out in Greenland, I guess, at this time. And then if I were to kind of zoom out here, I'm using my mouse wheel, by the way, to zoom out. And so now this is kind of a distorted view of the sky. This is like, they call it like the world view. It's almost like a fish eye, but in the most extreme way. So this is the sun right here in the top right of the picture. This is facing north, this is facing east, south, and west. And so what I'd like to just do is demonstrate what this looks like if I actually speed up the passage of time. So, see, watch what happens, you guys. You see how all the stars are basically rotating counterclockwise about a specific center, right? And that's going to be like around this star right here. That's Polaris. That is your North Star. And again, I can go back to being, like a regular person, just like not seeing the world in that very distorted view, and I can zoom in here. Right, and I can, look up again, and I can still see Polaris right there. And you can see also that Stellarium Web tells you some information about that star. It also tells you the altitude of that star, relative to this person. So we're not exactly at 90 degrees, we're actually at about 83 degrees. And so when this person is looking at Polaris, well, it's going to be at about 83 degrees altitude, because that matches the person's latitude in Greenland. Now let's go to the equator. So let me zoom out here. Somewhere near the equator. If you have the desktop version, it's actually much faster and it has a lot more features. But I do want to make it accessible for everyone. So maybe somewhere in Ecuador. I think Ecuador is like right here. Oops, I guess it's not working. Let me see. What if I just search Ecuador here? So this is good because you guys are seeing me kind of struggle through this website as well. So you can see me troubleshoot live. Okay, so let's go to Ecuador. Oh, I'm not sure why I'm doing that. I guess you have to press downwards on your keyboard and then press enter, hopefully. Okay, great, there you go. Okay, So you can see here basically what altitude you are. On the numbers that's basically defined here, you're at negative 1.33, so that means that you're like 1.3 degrees south below the equator. So I can like maybe bring that up a little bit more, a little bit higher. So that way we're actually at about the equator. Okay, that's close enough. Okay, I'm gonna use that location. All right, there you go. So I still have my atmosphere turned off. So the sun is right here. It's still actually daytime somewhere in Ecuador. And what I can do now is I will face east. So if I'm facing east, then if I speed up the passage of time here, so do you guys see that all of these stars are basically rising from the east, and even the moon just now, it rose. And if I were to face west, now basically that's where all these stars will be setting. The moon basically is about to set right now, and then with Saturn and Jupiter and Mars as well. And what I can do here is I can zoom out, and you can kind of see the stars going, rising from the east here and setting in the west. So they take on this like semicircular path. So you can see that there. Let's fast forward the day, and let me go back to the very beginning of this day on June 6th. So you can see if I increase the passage of time, you can see that basically all of these stars are still rotating about the North Star, the Polaris right here, right at the northern horizon. Okay, so now last one. Let's actually go to an intermediate angle, which is like, so let's put San Diego, California. So again, when you guys are using this website, just make sure as you're putting something on the search tool, press downwards on the keyboard so that you're actually selecting those auto-populated results. So I'm going to use that location. Okay, so right now it's about 8:30, I think at night. Yeah, 8:30 at night, and you can see I turned off my atmosphere again. And let's look for Polaris. Actually, now I'm facing north. You can see here that Polaris is right there, and you can see that its altitude is about 32 degrees, which is basically matching our latitude here in California. And if I increase the passage of time here, right, so you can see that some stars are actually able to stay up the whole time. Essentially, if they're able to circle Polaris above this northern horizon right here, and they're going to be up 24/7. So you can see that here, for example. If you look at one of the brighter stars from Ursa Minor, I'm talking about this star right here, hovering over with my mouse, you can see it's going to be up for 24/7. It's never going to set. However, anything that basically like falls below the northern horizon here, it's going to be able to set. Another thing to note as well is because if we're in the northern hemisphere of the Earth, stars will always rise from the east, but when they start traveling upwards, they're not going to travel straight up. They're actually going to travel south, and then they're going to go back to being north when they're setting. So let me just demonstrate that real quick here. So if I go to the next day here, and let me kind of just rewind a little bit. So watch what the stars are doing as they're coming out of the eastern horizon. So do you see how it's a diagonal path as we're moving forward in time? So if they're going diagonal to the right, that basically means that they're rising towards the south. And you can see that as well here, right? They're headed towards the southern direction, or the southern portion of the sky. And then when they're about to set, when they cross the middle here between the east and the west, essentially at the meridian, right? That's when they change direction, and the stars will now be traveling towards the northern part of the sky. So even though they're still in the southern half of the sky, they're traveling towards the north. So you can see that there. So now they're moving downwards and to the right. So now if I'm facing west, so we know that stars are going to be setting in the west, right? So you can see here that now they're going to be moving downwards and to the right. So right is basically northbound. Okay? So that's how we actually see the sky here in San Diego. So it's a little bit different. It's kind of a combination of what you would see in the North Pole or on the equator, which makes sense because we're at an angle or somewhere on Earth, somewhere in between those two spots. All right, so hopefully that kind of clarifies the unique perspectives that you would get depending on where you are on the surface of the Earth. I would also highly encourage you guys to play with the Stellarium web online. And in fact, you guys have an exercise on this. So you guys are going to have to learn how to use this stuff anyway to really better understand this. And again, I encourage you guys to go outside to actually test out these ideas for yourself. That's the best way to learn. All right, so that'll do it for this video lecture. I'll see you guys next time.